we're going to talk about databases today, and in particular about NMR databases or databases for NMR data. We have three main types of NMR databases in ACDLabs, and let me use my laser pointer. There you go. We have databases that contain experimental data. We have databases that are used for the training of our NMR predictors. And also we have databases that contain predicted spectra of known structures. All these databases are part of the Spectrus platform, so you don't need a different type of software to access them. Let's talk about the experimental NMR spectra databases. You can have either commercially available databases, such as, for example, from Aldrich or from Wiley, or you can have user-created, that is ones that you create with your own data. All these databases are managed through Spectrus DB. So Spectrus DB is the software that allows you to view and scroll through the databases. And all Spectrus platform programs can view and search these databases. So even if you have our lowest entry-level product, Spectrus Processor, you can still view and search our databases. All our Spectrus workbooks, like NMR workbook or MS workbook or Chem Analytical workbook, in addition, can create databases and add data to the databases. So with any Spectrus software, you can view, but with the workbooks, you can create and add. The experimental NMR databases can be, as we refer to them, as local databases or flat file databases, meaning it's a file stored locally on your computer, or they can be enterprise databases, that is Oracle or Postgres databases. They can contain any type of analytical data, not just NMR. As I said before, we have also software for MS and chromatography and other things, so this data can go in there as well. What is of real importance and interest is that they share the same database engine as the ACDLabs' advanced enterprise solutions, for example, Luminata. If you are familiar with this software, which is a software for managing analytical data in a development environment. So this is using the same engine as our standard databases. Of course, we have many options for searching, viewing, and managing the data. The NMR predictor training databases. These are the databases that are used for training the predictors. The current version of the system databases that come with the software contain more than 350,000 structures, and we keep adding structures every year with every software release. Our databases contain data for structures that are generally known. But there is a good chance that you are working with some structures that are not quite known or contain novel skeletons, and in that case, the predictions may not be as good as they should. For this reason, you have the option to create your own user training database that will enhance the prediction accuracy of our NMR predictors. An important thing about NMR predictor training databases is that they can store only NMR data. And actually, they can't even store spectra. They only store in principle chemical shifts and coupling constants and structures, nothing more. They are used, though, by all our Spectrus platform programs. So even again, if you have the simple Spectrus processor and you are doing some structure verification or whatever, these training databases will be used in the background, okay? But you can only view and edit these databases using our Predictor Suite software package. Third, the databases containing predicted spectra of known structures. These contain predicted carbon-13 spectra of all the compounds in PubChem. At the moment, this is around, it's more than 99 million structures. It's just shy of 100 billion structures. These are databases that we have compiled, and we are we are distributing. And they can be used for the rapid dereplication and competitive analysis and identification of known compounds. So if you are, for example, working in the natural products field and you are isolating novel compounds and you want to see if they are really novel or if somebody has worked with them before, then you can enter C13 data information, that is C13 peaks. And this can be in the form of either a carbon spectrum or a combination of HSQC and HMBC spectra. And then you can search these databases and see if there is anything that has been reported and is in PubChem that has a carbon spectrum that is similar to what you have. In the same sense, you can do also competitive analysis, so you can get your competitor's product and isolate maybe an additive and try to search PubChem and see what could that additive be. These databases are again available from any Spectrus platform program. However, you need an add-on, which we refer to as the known structures add-on. And this will allow you to use these databases. This option is included by default with Structure Elucidator. So I'm gonna stop with the PowerPoint now and jump into the software. Okay, I hope you can see my screen. This. What we see here is the starting screen of our Spectrus processor or NMR workbook, in this case software. If you want to go to Spectrus DB to see the databases, you just click this icon up here that says database. And the moment I click it, I go into Spectrus DB. You see up here, there is a title Spectrus DB. And here I have opened a database, which is actually one of the Wiley databases with proton NMR spectra. We see a screen here, and we see the spectrum, we see the structure, we see some additional information here. What I want to emphasize at this point is that this screen is fully customizable. So I can not only, expand and move these things around, if my mouse behaves. Okay, but you can also use our tools and create your own custom screen forms, as we refer to them, and make it look exactly the way you want it with exactly the information you want. For this reason, Wiley is actually providing this screen form here. And if I select it, you can see, in a much more compact view what you want. Now, you can go around the database and you can use these arrows to go to the next entry or the previous entry, or you can select this icon here and go to one particular entry, for example, entry 1, 2, 3, 4, 5, why not? Select OK. And yeah, it will go there. You can see the entry number down here. So this is, it's definitely a way of looking at the database, but you may want to be able to, you definitely want to be able to search. So let's see how we can search the database. And there are a few ways, obviously, and I'm going to show you the first way, which is searching through a chemical structure. So I'm going to go to ChemSketch, our chemistry drawing software, and I have drawn here already a structure. And I have down here, you see the options to search, and I can search for the exact structure or similar structures if I am very confident that it's there, or if I don't quite know, I may use the substructure search. And if I click it here, I see it's a bit maybe small, but it's down here. I click substructure search, and it's going to go into the Spectrus DB interface again, do a quick search, and tells me that there are 4 hits found. The moment I click OK, it's going to show me these 4 hits. It shows, for example, this molecule here, and the substructure that I had selected is highlighted in blue. I can continue here And again, this is highlighted and so on. Yeah, now what happens if I found a structure? If I found an entry in the database that I like, I want, I can just go on the spectrum, double click, and it's going to switch me to the Spectrus processor or NMR workbook. And here I can view the spectrum with all the tools that I have with all the tools that I have available there. So I can, for example, zoom here. I can scroll up and down. Now, just forgot to tell you one more thing. We can do the search in several ways. As I said, I showed you how to search by structure. We have a dedicated search menu option here, and I can go and search data. And here I can really define any search term that I want. So I can search according to the chemical name, whatever is in here. So everything that you see on the screen is searchable. So I can search by chemical name, I can search by solvent, state, whatever. And I can have terms like, includes, contains, equals, more than, less than, if we're talking about numerical values. And if I want, I can add more search terms. So I can have, chemical structure, chemical name contains ethanol and number of nuclei 5, for example. I could do that. I'm not going to do it now because it's going to take a bit of time. But I hope you get the idea. So, so we've seen how to search with structure, how to search with any of the other terms. What if you have just a spectrum? So I'm going to go back to the processor, and I'm going to click and drag one spectrum, one proton spectrum that we have here. I'm not entirely sure what this spectrum was. I think it was a pharmaceutical. But the question now is there anything in the database that looks like this? And for this, we have this search tool. And I can go here and define search options. To begin with, I need to define the databases to search. And it will search a currently open database, plus all these other databases, which are all the Wiley databases that I have right now. I'll go to search options. And here I can define what type of search I want. Do I want a similarity search or a peak search? If I do a similarity search, it will look for spectra that look the same. If I do a peak search, it will look for spectra that have the same peaks. Now, how could two spectra have the same peaks and not look the same? Well, they may have the same peaks, but for example, the database spectrum may be at a different field than the query spectrum. Also, some of the widths may be different, or some peaks may have moved just a little bit. I'm going to use a similarity search today, and I'm selecting the standard for comparing spectra, the so-called Euclidean distance. I'm going to click search, and it's going to go through all these databases. So that's approximately, I think, 300,000 compounds, 400,000 compounds, 400,000 entries. And after a little bit, it's going to present to me the result. And I see here with green my query spectrum, and with red the database hit. And I can zoom also here. And we see that the spectra look fairly similar. Well, obviously, the query spectrum has more residual water here. So that's why the similarity score is just 54.2, 54%. But this looks like it's a good possibility for being a correct hit. I can just scroll down on this table a little bit, and here is another one. And if we wait a bit, it's going to show the actual spectra. We see this has a lower score, and it's looking a little bit different. So you see, we don't have a triplet here. We have a more spiky peak there. So that's the way you can do the search. Of course, you get all the results here, like record ID and spectrum ID and whatever. And you also get the name here on the right. So yeah, that's how you do it. So let me close this result. So the next question is, okay, these were the commercially available databases, the ready-made databases. How can I make my own database? So let's go back to the Spectrus DB program. I'm going to close this database, close, and I'm ready now to create my new database. This can be either a local database, that is a database stored on your computer on a flat file, or it can be a remote database, meaning a database that is hosted with an enterprise database server, Oracle or Postgres. So if I click remote here, it's giving me a window to log into the database server, and you need to provide the host name, the username, and the password. I'm not going to do a remote database today. I'm going to do a local database. The functionality is similar for what we want to see. So I'm going to say database new. And it first asks me to give a name. I'm going to call it maybe, I don't know, test DB, test DB, and click save. By default, it will ask me to define passwords for reading the database and updating the database. That is browsing and searching or update it. If you want to protect your database, you enter a password here. If not, you just click OK. And then you get a message that compression is going to be applied, which is something good because your database will occupy less space on the disk. And I say yes. And now I get this initial empty screen. That is, I have a database with no records, and we need to fill it. So let's go back to the processor. And I'm going to bring in a fully processed data set that I have here. So this is a data set that contains a proton spectrum, a COSY spectrum, a carbon spectrum, and I also have a structure. So sorry, let me dock this thing down here. Okay, so I have all these spectra, and I have my structure. So if I want to add it to the database, I have to click this update database icon. And if I click the little arrow here, I get the option, I get to see some options about this update. So you can either update a single spectrum or the whole project. In this case, I'll update the whole project. And it's going to use, the test DB, the database we created. If you want, you can specify other databases, or you can have also some options for updating the project. I'm not going to go into too many details. And then I'm going to click here this update database, and I see the message it's updating the spectral documents. And after a little bit, I'm switched back to the database program, Spectrus DB, and now I have all my information here. I have my COSY spectrum, my structure, all the information. If I select here, I see my peaks, and if I use this icon to go to the right, I can see the rest of the spectra. Now, as I said, this look of the interface is something that's fully customizable, and we have extensive tools for creating custom so-called screen forms to arrange the data in exactly the way that you want. So don't believe that this way is the only way to view things. So yeah, that's how you add records to the database. If you now want to add the next one, you go back to the processor, you load the next data set, and you update, and you continue like that. So this covers the experimental data NMR Spectra databases. I'm going to talk very briefly about the predictor training databases. So if you have as it is here, you have a structure that has been fully assigned, and you have the spectra. You can add this entry to the predictor training database by going into database and update carbon and proton NMR database. I'm not going to talk much more about it. We had a webinar a little while ago talking specifically about our predictors and how to use these things. Plus, we have many other resources showing how to do this. What I can say is that if you are working with novel chemistries, novel skeletons, it is highly recommended that you create your user training database, as this will improve the performance very significantly. Okay, so the final type of database I want to talk about is the database of the known structures. And as I said in the introduction, this is a database that has predicted spectra of more than 99 million compounds, carbon spectra. So the way you use this database is you start with carbon information, and for this reason, I'm going to bring in a carbon spectrum. And this is a 1D carbon spectrum of retrofsyn. It's not obligatory that you have a 1D carbon spectrum. You can have an HSQC and an HMBC and have peaks from there. I'm going to do some peak picking. So we have our peaks here. Yeah, as I said, this is a sample of retrofsyn, I believe. And if you want to do the search, you go to search spectra of known structures. You click this icon, and this is the pop-up window that allows you to search the databases of known spectra. There are a couple of things that you need to set up here. First thing is how many peaks would you allow to be missing from the database hit, and how many extra peaks would the database hit allow to have. So you will not see a peak in your experimental spectrum if, for example, it's a quaternary and it's of low intensity. However, in the database, there will be a peak for that. So you want to maybe have a bit of a tolerance there and allow some peaks to be missing. In the same sense, you may have some extra peaks. So you may have an impurity in here in your experimental spectrum that you didn't know of or couldn't identify. And this would not exist in the library in the database spectrum. So again, in this case, you want to allow it to have one or more peaks missing, depending on how good quality your spectrum is. For today, I'm going to leave it to just 1 and 1, so 1 extra peak and 1 peak missing. It's also very useful to define either the composition or the molecular weight, if you know them, because this is going to speed up the search. And chances are that if you are looking for something unknown, that you have the molecular weight, you have probably run a mass spectrum. In this case, I'm going to set it from 351 to 352 molecular weight, because that's the molecular weight of retrofsyn that we have here. And here we have now all the database files that will be searched. Obviously, 99 million entries cannot fit in a single file. So we have split it in quite a few files. And yeah, that's about it. I'm going to click OK. And the search will start. So what we see up here is the system going through these 99 million compounds, first filtering them by molecular weight and focusing only on the ones that are in the range that we defined. and then searching for the actual peaks. And you see that it's going through, and down here you see a count of how many structures it has found. And after a little bit, it's going to present to us with the result. So to begin with, it's telling us that 79 stereoisomers have been excluded. So these databases contain several stereoisomers that are indistinguishable by NMR. So the entries are in there, but they are excluded so as we are not confused. So I'm going to click OK here, and I see that, yes, indeed, the first result is actually retrorsin, as expected. And up here, we can see a comparison of how similar are the query spectrum that we had and the actual hit spectrum. And I can go to the next one and see how better or worse this one is. Again, we can see that, yeah, all peaks are there. Yeah, of course, there are some slight differences. There may be, as we said, an extra peak or a missing peak, but this is exactly what we set up in our search terms. So, yeah, within a few seconds, it went through 99 million compounds and found what has similar carbon peaks, which is quite a powerful technique. Now, you may say that you don't actually have the spectra, but you know where the peaks are. In this case, let me go back here. So in this case, you have the option to set the search query manually. And if you select this and click again the search, yes, then you are presented here with a window to type manually the peak frequencies that you want the system to search for in the database. So as I said, this is used for searching, yeah, things that are known, but also it could have another possible use, and that would be to search for things that are not generally known, but they may be known to you. So imagine, for example, that you are doing metabolite analysis and you have your starting API, and you know what are the possible metabolites, and you have isolated some, but probably, yeah, you definitely don't have reference spectra for all the possible metabolites. You have, though, their structures. So you could predict the spectra for these possible structures, and then use the experimental results that you have and search these possible spectra to see if any of the metabolites you expected is the one that you have isolated. The way to do this is you go into Tools and you select here Create ACD Structure Database. And in principle, you just have to add an SD file that contains all these structures, define an output folder, and click Run. And then these databases will be generated. And then you have to enter them as the databases to search for. So that's all with this. So yeah, that's what I wanted to show you in the software. So we can go back to the presentation. So yeah, in conclusion, ACDLabs offers a variety of database options for experimental and theoretical NMR data. And all the options are managed through the Spectrus platform. This gives you the highest flexibility, and it also gives you a gateway to our more advanced enterprise database solutions. All these tools that I showed you are in essence the same as to the ones in our higher end solutions.